Hello, everyone. Welcome to the Canadian Electricity Association's Conversation webinar series. I'm Janice Garcia, Corporate Secretary here at CEA, and I'll be your host for today's webinar. CEA has worked with our corporate partners to develop this conversation series, which focuses on solutions to current and future challenges faced by our industry. Today, Siemens Canada will be presenting utility distributed energy resources adoption with the Energy System platform. The energy system is currently undergoing many changes today, from decarbonization, decentralization, and digitalization. The energy transition is challenging and might lead to consumer price increases and lower profits for utilities. Siemens is going one step further by working with its utility partners to provide the energy system platform of the future. Our presenter is Jacob Picklemeyer, Program Director, Smart Grid Atlantic. Before we get started, feel free to type questions into the question area on your webinar screen. We'll ask those questions at the end of the webinar. Later today, we will send out a recording of the webinar along with a post-webinar survey. We certainly appreciate your feedback and are very much interested in any topics you would like to see as part of this conversation series. You can also access a PDF of this presentation by clicking on the handout section on your screen. Jacob, I'll now turn the webinar over to you.
Thanks a lot, Janice. Very glad to be here. Welcome everyone to this conversation series. We're proud to be invited to contribute today to that conversation, as there are indeed many things to be discussed in the industry at the moment. So let's get started right away. Warm welcome once again. I'm talking to you today from my home office in Toronto, where I'm grounded, as probably most of you are at the moment in the home office. And yeah, looking forward to the discussion with you all today. So let's go into the content right away. The introduction has already given a hint at that. We are in the middle of a major transformation in the industry, in the utility industry, specifically electric utilities. And that is driven, as everyone knows, by the famous 3D in the market, the decarbonization, so environmental reflections, the decentralization, transition for you could say, from a more cardiovascular electrical system with central generation assets and electricity being distributed to all the consumers on the lower levels of the grid, to a more, you could say, lymphatic system with a lot of decentral hubs of generation as well as consumption. With all kinds of implications. You might have a reversal of power flow in the electric grid when there's a lot of solar production on rooftops. You might have extreme peaks for loads for e-vehicle charging and so on, but you might also have customers that have bought from the grid reliably in the past and are now generating their own electricity, becoming prosumers, becoming net zero homes or entities with obviously quite some dramatic implications for the classical business models in utilities. All of that is, which is a big benefit, accompanied by the arrival of the Internet of Things, of smart devices talking to each other, and the digitalization of the energy system. And we at Siemens believe that that is truly one of the best levers to address the different challenges that we're facing in the industry. So these challenges are to go nowhere. They are to stay, and they are to multiply over the course of the next years, with not only a dramatic increase of the electricity consumption overall, not only from population growth or immigration like in Canada, but also from the additional electrification of sectors like mobility and heating. We see that there's more and more renewables coming up, and also the current health crisis that we all are affected by has increased, from our understanding, the desire to find solutions also in the energy space that give us more resiliency. Here in Canada, we also have specific effects with severe weather events and so on. So a lot of challenges coming at the sector, and digitalization as a main lever to help us address that. Let's quickly talk about the challenges in a little bit more detail. I believe we have a real utility audience today in this conversation series. So some of the challenges that you might be facing and that you've already encountered can range from the natural intermittency of renewable power generation. It is more difficult to forecast the generation. It is more important that we look at flexibilities in the system to accommodate that. Traditionally, that could be done with backup power generation. It could also be done with demand flexibility and so on. So these things are definitely one challenge. Another challenge, the resiliency. Upholding a smooth grid operation is obviously quite important. You have other elements that are more on the business side and on the regulatory side. There is a substantial political desire to limit the cost implications of the energy transition. This might all become quite expensive. Just think of things like in Europe, where you had a lot of subsidies going into renewable energy that has multiplied the challenges for the utilities very early on in the game. And the expectation is more or less that the industry finds ways to deal with that in a more or less cost neutral way, or at least with a minimized impact to the ratepayers. You have beyond that, all kinds of new technologies, still a lot of uncertainty, not only with the prosumers, which PV panel to pick, which electric vehicle charger to pick, how should I set up my home, what can I do to maybe foster the green development of the sector, but also on the utility side, what's the right systems for tackling these challenges, what's the right business models going forward. What about customer defection or load defection? How do we balance that? And on top of it all, obviously also cyber challenges. The energy system is one of the most vital systems to run society and needs to comply with the highest standards of reliability. And that obviously is not only on the physical and on the operational technology level, but also on the IT level. So cybersecurity also plays a big role. Traditional business models under a squeeze, we need to find new ways. So this is the setting. Why we are talking to you today is also because we have started an initiative here in Canada from which we wanted to share a couple of findings and a couple of insights and provide that as an input to the discussion that we're having here in the industry to shape that future together. Siemens has, in this partnership that is called Smart Grid Atlantic, joined forces with two utility partners, New Brunswick Power and Nova Scotia Power. Together we are receiving funding from the government in creating intellectual property here in Canada, creating a knowledge and a competency cluster, which for Siemens is also a hub in the global development. And besides my role here in the project, where I have the pleasure to work with a great team to deliver this initiative, we are also acting as a cluster in the global structure of Siemens, defining and shaping the future DERMS offering of Siemens globally. So this is quite an interesting and cutting edge initiative. Siemens is very much committed to. The general idea here is to broaden the understanding and to develop the right mechanisms for DER management, so the management of distributed energy resources in the future, in a platform that the utility would be operating to get the transparency on the assets, to engage with the customers through programs, and to provide grid services. I will go more into detail on that. So on the higher level, it is about a cloud-based IoT platform that connects all the dots in this distributed energy landscape. It is a public-private partnership. We're working with the communities, for instance, the town of Shediac or the town of Amherst, and we are, like you see here, connecting a whole array of different distributed energy resources. And that really spans a lot of different scenarios. It goes from residential devices like solar PV on the rooftops, e-vehicle chargers, smart water heaters. It goes on to fleet applications or to CNI, so commercial and industrial applications, be it generation, be it storage, be it load integration. And it even ranges to entire microgrids. So we are also connecting two communities that will be on the equipment level and on the local level optimized by a microgrid configuration and a microgrid controller. And those microgrids as a whole will also be integrated into this platform to demonstrate the capabilities of, for instance, integrating remote communities in concepts like that. With all these distributed energy resources connected, we have certainly left the stage of a lab environment. This is a real life test bed for 2 or 3 years to give us insights, also the utility partners insights on the business models and how to define the collaboration with prosumers and grid edge devices in the future. We are going through the heavy lifting on the program at the moment. We've successfully deployed the first couple of releases to the utilities and are working on expanding the integrations to the actual target state over the next year and a half. We are also on track with our commitments to the government, so the initiative is running quite smoothly at the moment, and we're excited to see what's coming out of that and which learnings we can yield. We're right now integrating with the first DERs and will start the pilot operation in this winter. So how does this initiative here in Canada fit to the whole discussion? We have decided from the Siemens side to join forces with utility partners to develop that as a product, but as I've said, it also will eventually emerge from this cluster as a global offering and as a Canada-wide offering, obviously. So let me link that back for you and explain to you a little bit what our understanding of the market and of the evolution in the market is, specifically talking about the management of distributed energy resources in utilities. That is, as probably most of you in the industry know, that is a journey, quite a journey, and a lot of different things that need to be put into place from the regulatory perspective, from the utility perspective, and also in the customer adoption and acceptance of models. What we see, and here it helps that Siemens has been accompanying utilities for about 20 years, probably, or even longer in the energy transition, and we've seen the development and the emergence of different use cases and applications in that space and have supported that with software offerings before. So let's start here with the first step that you see on the slide, demand response. This is very much what's the cradle of the industry in North America. So in both the US as well as in Canada, the focus was very much on loads in the beginning. Simple reason being that conventional peaker power plants are quite an expensive investment, and it's relatively easy to make a case for shifting peaks and avoiding backup capacity to address that business case. So this was the main focus in the US for a good 10 years or so. In Europe, we've briefly talked about that a little bit earlier. In Europe, the whole energy transition was very much driven from the policymakers and from subsidies. We can tell from the background in Germany that was quite a sharp transition through very extensive subsidies in distributed energy generation equipment, mainly solar rooftop PV. And that was basically charged or burdened on the ratepayers. So in Europe, through that, we've seen basically consumption rates of 30 euro cents or 25 euro cents, which is outrageous levels as compared to what we are seeing in Canada, and would definitely not work from a political standpoint. So in Europe, the focus was more on the generation side with all that build out happening. And the first applications were what is called today virtual power plants. So aggregating ideally a somewhat diversified pool of generators, be it diversified in terms of generation type, biomass, wind, solar, and so on, and maybe also geographically diversified a little bit in the south of the country, in the north of the country, whatever, so that you were able to forecast that, to know what's coming at you, to integrate with weather forecasts, and to be also able to offer energy and ancillary services into markets in Europe where everything is strictly unbundled. That would be typically bidding it into a TSO market. Yeah? So these applications dealt with the intermittency of renewables. Both concepts are still very much in use and still very much legitimate. What we see in that area is that this whole area of demand response and virtual power plants is dealing with visibility and with aggregation of flexibility. It does not ultimately matter whether that flexibility comes from a generator or whether it comes from a load. So we see that these two areas are growing together. It is about integrating a pool of distributed energy resources that form the basis of your flexibility. Storage, for instance, is not clearly a load, is not clearly a generator, it's right in the middle. You still need to deal with it. For demand response, that's more a specific application during a specific time. A virtual power plant can be scheduled for whichever purpose you want. So the mechanisms are maybe a little bit different, but it doesn't matter whether it's load or generation or storage. We are using and offering both mechanisms, and we understand them as a way of reaching out to devices to help all kinds of purposes on the utility side, be it on the DSO level or on the TSO level. And that is really the next evolution that we see in the market. Again, North America is leading the pack from our understanding in that regard, mainly in the US, driven by the incredible pressure on utilities on the distribution level to deal with PV in-feed in sun state like Arizona, but also to deal with e-vehicles being connected. And we see that while demand response and virtual power plant in the beginning were ideas on the transmission level, how do I balance the total supply and demand in my geography, are now converting into more and more business cases and use cases where you very much look surgically at where the impact is occurring. So looking at a feeder level, at a substation level, at a transformer level, where are the most critical challenges, and where can the conventional build out of poles and wires and bare metal equipment be avoided, or at least complemented and reduced by the use of technology to integrate distributed energy resources. So you could say you have a problem in your feeder, you detect that on your advanced distribution management system. There is a proposal calculated how you could resolve that constraint violation and deal with it. And besides traditional utility assets like a tap changer, like a capacitor bank, like a switching procedure, you would now have contracts, if you will, of flexibility at your hand or at the tip of your finger that you can activate, and you can try and curb consumption or increase generation or incentivize backfeeding generation and excess generation instead of locally storing it, and so on and so forth. So all of this can now be the same pool of resources that have served a system level purpose or a transmission level purpose before, can now also be used to serve a distribution management purpose. The biggest stepstone to that is really on the utility side, getting transparency into the distribution level, the arrival of advanced distribution management systems, and them starting to go beyond pure outage management systems with more transparency on the grid, a grid model, the ability to run state estimations and power flow calculations. In Smart Grid Atlantic, we're even going one step beyond that, if you will. So besides DERMS, which is oriented towards the distribution system operators and their network management, we are also covering an aspect in the program that we believe will play a big role in the future, and that's transactional business models. So how do people engage in community trading or peer-to-peer trading? What concepts for pricing, maybe even nodal pricing, will come up in the future, and we're trying to anticipate that and experiment with that to also be able to cover that in a productized offer going forward. Having said that, I'm proud to say that we got selected earlier this year by one of the leading analysts in the industry as a #1 provider for DERMS. Is that because there's some secret sauce or some magic technology? Probably less, but what we see in that distribution field when we're talking about DERMS, it is about combining the approaches from the business and customer or consumer oriented sides in the utility with the grid operation and more operational departments within the utility, but it's also on the software side, connecting grid control systems or advanced distribution management systems and adding functionality like what we've described, getting situational awareness of the distribution grid and linking that to offerings that have existed before in the distributed energy resource management space. So aggregating distributed energy resources, engaging with the customers, enrolling them into programs. And as we've seen throughout the presentation, Siemens has a strong coverage in both. We do both. We do DER management software and we do advanced distribution management systems. And as opposed to some of the other players in the industry, we don't need to partner to deliver a solution. And we are able to integrate that in different scenarios and at different life cycle stages of the utility. So coming back to that idea, also on the utility side, there is quite a journey. We are working with customers that have a more basic SCADA or distribution management system in place, and we're bringing in a broader functionality in DERMS. We're working with customers who have a very state-of-the-art ADMS already in place and are looking to enable broader DERMS use cases, looking sometimes more for the customer-oriented or DER management-related functionalities. So at the moment, this is still, from our understanding, a system of systems approach and a market in which things are still being defined. And we are very excited to join partners and to find partners to lead that innovation in the sector together. So DERMS, as we said, very much talking about the distribution management constraints and how to resolve them or how to help resolve them with distributed energy resources. Just one comment maybe for those of you who might be more on the distribution network operation side. What I find very interesting and important in our concept is that the user interface to a grid operator should ideally not change, right? So you have a complicated story in the background to integrate with all the distributed energy resources that can be a crazy mix of utility-owned assets with direct communication of residential devices that are cloud integrated in a vendor cloud. It might be previous integrations through aggregators that the utility has already gone through and established programs. All of that needs to be brought together, but to the operator, it should look like one more lever that he can use to resolve a certain constraint. So that requires a synchronization on the grid model and a dynamic aggregation of the devices that provides that flexibility and that forecast. And it can then serve a wider array of purposes from our understanding than just DERMS, but it can very well serve that purpose as well. For those on the customer side, I believe that what we're experiencing early on now with our partners in Smart Grid Atlantic needs to be somewhat simple for consumers to be willing to engage in that offering. At the moment, it is still somewhat always subsidized from the utility perspective in whichever form and through incentives, but to think about real business models that will carry in the future and will carry beyond pilot stage is very important. And for the customer acceptance, none of this should really impact their convenience or require all too much of an interaction on the residential level. So that's one finding that we see. It needs to be something that is doing its trick and optimizing in the background and optimizing in real time or in near real time and support all kinds of cases with the magic being hidden to a large extent behind the curtain. So to summarize that, we have talked about the energy transition and how this is impacting utilities, renewable energy, decentralization, electric vehicles, and so on and so forth. We have talked about digitalization as probably our best way of handling that and of dealing with these challenges. And we've talked about our contribution on the Siemens side, both here locally in Canada in the Smart Grid Atlantic initiative, and building on that as a competency cluster also for our global offering, and where we see that the market for software that is managing distributed energy resources will be going. In the beginning, if you recall, I said there might be a fourth D. Some people say there's also a democratization happening in the energy market. And we talked about load defection or customer defection before in the presentation. So we also see that movement, specifically when you're talking about peer-to-peer trading, that somehow sometimes seems like being associated with very energy liberal movements of people really trying to get grid independent and to disconnect and to emancipate from the utilities more. And we at Siemens really believe that that is probably a valid agent or driver for change, but the utilities will be required in the future. The utilities are in much better shape than individual users to discover the technological possibilities, to condense them into an understandable offering for people who want to be part of this, thereby engaging the private and consumer-owned investment into generation assets, into storage, into equipment that can be used to run the system. And someone will still, from our understanding, be required to run that system and to tie the dots together. And we believe that the utility has a major role here also for carrying risks. If I look at myself, I would like to invest in distributed energy resources for sure, but would I want to carry the entire risk of creating a backup, of ensuring my own supply security in all eventualities? So the utility is still very much required, and we believe that the utility has a good opportunity to gain and retain a key role in that new energy market that might be evolving, also depending on regulation. But we believe that flexible concepts that think the energy system as marketplaces or as a marketplace that could very well be utility operated, and it could build a platform for incentivizing people to engage with the system, to invest in decentral resources, to provide the flexibility from these distributed resources to the system, to make them accessible to the community for a better optimization together than you could ever get if you're optimizing individually on your own account. So this is an important function that is required to be filled in the market and that we believe utilities will be growing into, and that we are most excited of supporting with software offering that can help you do that and can help you establish business models to incentivize, to buy, and to manage the flexibility from distributed energy resources. So thanks a lot for the opportunity to showcase and to display a little bit our thinking and our understanding of the market as it is today. And I'm happy that we have a little bit of time now to go into a Q&A session, and looking forward to answering the questions that you might have following this presentation.
Jacob, thank you very much for an interesting and informative presentation. A few questions have already come in through the chat function, but a reminder to participants to please use the chat function and type in any questions that you may have. So we'll start with the first question. Are there regulatory barriers, both here in Canada and in other jurisdictions, that Siemens is engaged in to moving forward with this vision?
So thanks a lot for the question. That's a good question. Both here in Canada and in other geographies, there are definitely regulatory questions and regulatory challenges still on the table. Let me give you one example. Like we said, for transmission level or TSO level use cases, bidding energy and ancillary services is, at least in Europe and also in North America, quite an established mechanism, and we know how that works by now. There's still some changes underway, also with virtual power plants in the US, for instance, now allowing much more assets to contribute to system level services. But on a distribution level, that's quite an open space. So it is not yet clear here and also in other geographies what the marketplace will look like for prosumers to offer distribution level services, for retailers and distribution utilities, how they will contract that flexibility and how it will be eventually traded or offered between utilities. So that is an open space, and Siemens is engaged in that discussion because we feel the pain of our customers and of our utility partners, but also is sometimes part as an expert advisor or as an input provider in political discussions, obviously to the degree that we are asked to provide opinions. But we're not influencing the policy making, so we're a recipient of that, much like the utilities, and it's maybe discussions like this in the community that can also help bring about changes and align changes.
Great, thank you very much. We have another question here. Do power utility companies need to completely change their current non-smart meters?
Also, very good question. Thanks a lot for that. So, is the energy transition possible without smart meters? I would say probably it is. In Europe, that's not as widespread as in North America, and it has still worked somehow. And sometimes even if you have smart meters, it doesn't help you either way. So what we see regularly is a challenge where on-site generation is hidden in the consumption. And you basically see a net consumption through your smart meter, but if you don't have a sub-meter or any other way, could be a cloud integration or something like that, that gives you visibility to the generation device specifically, you will miss a point in forecasting the load or the net load coming from that home just by looking at days of times of the day or times of the week and so on. So it's important to get that visibility into the assets that are distributed in the field, not for everything, but for the larger topics that are more important and play a bigger role in the province, in the geography, and the territory that you're serving. And it is important to get that visibility either through smart meters, which helps a lot, or in other cases, maybe also through other means and mechanisms.
Great, thank you. Another question, how far along is your energy system platform from being commercial ready? When will your pilot be completed?
Thanks a lot. Yeah, we have both very good questions. So the program in total is set to run until March of 2023, but that includes a longer period of demonstration and pilot operation on the utility side. So if you will, the development on our side to enable the pilot is much earlier in the timing. Major milestone will be definitely at the end of next year for an integrated package and offering that enables all these functionalities for the pilot demonstration. And I mean, if you look at Siemens globally, we're also working with other utilities, and we are already offering systems and software in that space. ESP is a local Canadian deployment, and we are, I would say, always ready to discuss with potential interested parties to maybe also build on Smart Grid Atlantic, make it larger, make it broader, bring it to another province, and we would be prepared to and willing to engage on that today.
Great, thank you. Another question here, for the customer to benefit from the DER and peak savings, who owns the data and who will be connected to make the pilot worthwhile? Or sorry, from customer to benefit from the DER and peak savings, who owns the data and who will manage the data transmission to and from the power companies?
Thanks a lot. Yeah, that's also a good question, and it sheds some light on what's the challenges in the industry and in the software in that space. Typically, what we are seeing is that a lot of that is handled through a customer management system on the utility side. So if you have an existing tool, be it Salesforce, be it SAP, DSM, there is typically a solution that will be in front of the customer, and usually that's also handled for the majority of the customer information and of the data. For the device data, that is really that's a broad field, and we could probably spend a lot of time just on that question, because it really depends on who's owning the asset. Is it the utility's own asset, or is it a prosumer asset? If it's a prosumer asset, it might depend on which device you're using. So look at companies like Tesla. They are basically trying to close their ecosystem in some areas and retain the data, and you can access pieces of the data through an API. In other cases, you're buying more raw equipment, if you will, an individual battery, an individual inverter, and you might have much more access according to IEEE 1547, for instance, to have local communication to the device and be much more interactive with it. So it depends very much on the device, on the prosumer who's owning that, and on the contractual situation with the utility, and also the utility systems that he's using today to manage his customer data. And a DER management system does not necessarily need to get involved with that. It can usually deal with the locations of distributed energy resources and participant numbers, if you will, to handle the data it needs to handle.
Great, thank you. Is Siemens providing capital equipment for this solution, or is it a cloud solution that plugs into existing customer data points?
Let me think about that question and try to answer that right. I hope that I got your question correctly. Is Siemens providing a capital investment? First, let's maybe answer that. Yes, we are. The total project volume of Smart Grid Atlantic is a little bit more than 90 million Canadian dollars. That comprises the Siemens contribution, but also the utility contributions, and involves all the communities that you've seen, and assets as well as software. there is a substantial contribution or Siemens investment in that as well, which relates to the development and I should say perfectioning or taking the software offering to the next level in that area. And that is our own investment. What I think you might be asking about though is what's the deployment model for that? So we said it's a cloud solution. We are offering that in Smart Grid Atlantic through a software as a service model to the utilities. So there is no equipment or infrastructure investment required on the utility side and also not on the Siemens side to stand up that infrastructure. We are providing that, but we're providing that together with a cloud computing partner.
Great. How is the size of a pilot determined? How many customer elements are required to be connected to make the pilot worthwhile?
Yeah, that's a good question. I would say we try to reach for the top and integrate all kinds of complexities that you would potentially come across in creating a system like that. We have a very broad array of different shades of directly connected devices, as we said, of vendor aggregations and integrations with their clouds, but also with residential devices that we integrate and communicate with directly. So it's a very broad array, also connecting the microgrids, and it is worthwhile for us already to do that with what we're providing. There's a lot of innovation also in the business model, like we said, software as a service, all of that cloud-based. We're dealing with multi-tenancy and other architectural phenomena that are quite interesting to have a look at, and we're really leveraging that platform. The more complexities you integrate, so to say, the more challenges you address, the further you would get on the innovation side. But what we are also keeping in mind for the utilities is there will be things and business models and integrations that we go through, that we implement, that we demonstrate. And it is very important for the acceptance of the energy transition to migrate those good examples that you have and those best practices into production programs quickly to spread the word, to capitalize on what you've already learned. So it is very important that the industry is moving past the pilot stage, I believe.
Great, thank you. Next question. Does Siemens have their MDM strategy? And does your data structure comply with the green button data?
Yeah, thanks a lot for the question. So, of course, there is an MDM or a metadata management strategy in place. You know that Siemens offering in the metadata management space is the Energy IP platform from eMeter, which is also a local provider, at least in North America. They are sitting in the United States, so they have an MDM strategy, and it is aligned. So we have basically, you could almost say in that software space, there's three different offerings or areas of offering, which is the pure play grid control software or the pure play metadata management software. And the DER management is a little bit in between. It interfaces with the grid control side because that's basically the user of that flexibility in the DERMS future. On the other hand side, it builds on the technology that we are also using for meters. So one benefit definitely of the platform is it is production ready. It is a very established and proven technology, and it's very scalable, because in metadata management, you're by default dealing with millions of endpoints and you're aggregating large amounts of data, and that is capabilities that the platform brings, and that helps with scalability.
Great, thank you. Next question. Is your ESP platform focusing on DER participation in distribution level markets and wholesale level markets? What are some of the initial use cases you are focusing on with the ESP?
Yeah, very good. So very good question. And In principle, yes. Maybe you recall from the presentation, I was showing this staircase with 4 steps of the evolution of the use cases, and in Smart Grid Atlantic, we're really covering all those. So it is for distribution level and for transmission level or wholesale level transactions or use cases. And we look at loads, we look at storage, we look at generation, and we look at all kinds of different programs that range from more planning functionalities like day-ahead energy trading or day-ahead scheduling of demand response events, peak shifting, and so on. But it ranges to much faster responding intraday, hour ahead, and even regulation cases, which is then typically more seen on the distribution level. So it's very different timescales on which these programs are run. And as you've seen before, and maybe recalling, we also have programs that are not focused so much on the utility service on the distribution or on the transmission level at first, but that are really focused at enabling the interaction between participants in a community. For instance, in peer-to-peer trading, if your battery is empty and you still want to charge your e-car and your neighbor has that flexibility, how can you enable that as a utility?
Great, thank you. Next question. How does Siemens intend to address the data privacy concerns on the smart grid?
Yeah, thanks a lot for that question. I believe we've already talked about cybersecurity and the importance of cybersecurity to ward us against potential cyber attacks from which vector ever and from which actor ever. But you're raising an important point. So Siemens is very familiar with that. You might know that the European Union has quite high-level privacy standards. So we comply with all the standards that are typically referenced in the industry on the technology side in the software. And Canada also, that's maybe worth mentioning in this regard, is also developing into a global hub for Siemens on the cybersecurity side. So in Fredericton, New Brunswick, there's a new center of competency being established for cybersecurity with a very impressive facility to also host critical data and to deal with services of this kind. So that's quite an interesting field and a lot going on. As I said, in the DER management space, if you look at the applications that we're discussing here, there is not that much of a customer information being handled, right? So you could have challenges along the communication channel, how the device communicates to a cloud, how a cloud communicates to a cloud. That is all very much state-of-the-art architecture to give you the highest possible level of security. And the utility and the owners have to contribute to that. So high security data security is also physical security on site, and managing the customer's private information is probably in a lot of the cases that I'm working with more a challenge on the utility side than on the Siemens side. But for what is happening in our systems, we comply with the requirements, whether it's PPDA here in Canada or other privacy regulations in the US and in Europe.
Great, thank you. Next question. What is the most pressing issues on load forecasting for the power utility companies?
Yeah, thanks a lot. A very good question, and it's also one that's keeping me up at night now that we're all grounded in our home office. I'm bound to sitting here all the time and thinking about the future of the grid, and it's a very good point. Let me take two angles at that, and it's probably not comprehensive, but one we mentioned already. When a utility is looking at the net consumption from households or from industries, and those industries or households start doing things with distributed energy resources behind the meter, your home battery, your home storage, your home, and so on. You would typically, the algorithms that are forecasting the load and the demand in utilities incorporate weather, but more in terms of the temperature. Will people be cooling? Will people be heating? And not necessarily in terms of the solar irradiation or the wind speed, which would drive your generation. So in fact, there's something happening behind the meter and you don't know why, but the load is somewhat funky as compared to a regular pattern that you would expect for that industry or for that household. So getting the separation and the transparency on what you have in the field and not just collecting net demand on smart meters, that is probably one of the bigger steps. The other big movement that I would like to mention and that I see in the industry is, we talked about Europe in the beginning. It was driven by renewable energy build out. Everyone built its own pellet heating or electrified his heating, or built a solar PV panel on his rooftop, or installed a battery and so on. So it's very much this grassroots type of renewable investment. And it was kind of always limited to who has that challenge. It's only the geographies like Arizona, like Nevada, like Texas, like sun states, Spain, Italy, I don't know, things like that. And Canada was somewhat shielded from that. It's not that outrageous. The business case in itself to install PV on your rooftop is not that big. If you can install a battery and a PV, it gets better. If you can lend some of the flexibility from your battery to the utility and get an additional income, it's getting much better. And besides all the renewables, what we see is there's now e-vehicles, and e-vehicles is a completely different thing. It depends on the attitude of people who want to buy that or not, and it maybe depends on Tesla coming out with something in the 25K range. If that happens over the next couple of years, we'll see a huge insurgence of electric vehicles. And the way they are being connected and integrated today poses a major challenge to the distribution utilities that will affect most presumably everyone in North America to a much larger extent than renewable generation penetration in Canada.
Great, thank you. Next question.
So, forecasting e-vehicles. Yeah. Sorry, thanks, Janice.
Where are you seeing the biggest bang for the buck regarding controlled devices? Water heaters, thermostats, solar, wind, EV chargers, or others?
Yeah, very good question. And I would probably almost use an analogy to the financial sector here. I believe that diversification is quite good. It's not good if you run a pilot and you try and integrate with 100 different devices, but you scale none of the programs to a production level and roll it out across your territory. But it is good to look at different forms of DERs, because the different forms of DERs imply different things that you can do with them. Let's take an example. If you want to move demand on a larger scale, you need to discuss about industrial customers as well. You cannot just reduce the consumption from an industrial plant in an automated fashion. You typically need an event mechanism that allows the entity to look at that request and to opt in or to opt out of an event, depending on their production process and whether they can accommodate that. So this is one example. Another example is if you have a water heater. It has a great thermal storage potential and can definitely move the needle in residential programs, I would say. So very powerful source of flexibility. But in many cases, other like maybe heat pumps, it is a one-way street. So you can basically increase or decrease your load, but you can not increase generation. So, and it's also maybe not as fast responding as a battery would be. So you're always looking for a mix. If you have a bad storm event, if you have a bad natural disaster or something like that, how is the system still cellular? How is the system still resilient in a way of having different assets at its disposal? Some things might not work on a hot summer day. Some things might not work on a cold winter day. So it is a mix of resources depending on the constraints that you have on the customer side. What can you do with that device? How often can you dispatch it? Do you need to ask for permission, sort of? And depending on the capability of the devices, is it a second basis reaction? Is it a minute basis reaction? Is it a hourly basis reaction? So that really depends on the device capabilities.
Great, thank you.
Sorry, maybe to add one last thought, because it came from the users. Depending on those capabilities, it will fulfill different purposes for the utility. So what's the biggest bang for the buck? look at the utility challenges. What's the 2 or 3 big themes? You have a morning peak, you have an evening peak, you have a cooling peak around noon. So that's different patterns, and which assets lend itself to help you with that main challenge. And we also believe that DERMS, for instance, will not be rolled out across entire territories modeling every substation. The biggest bang for the buck is where you have a constraint today in the grid, and you need to avoid making an investment into that. So you would maybe also look at, what do people in this region have? Is there a lot of PV? Is there a lot of e-vehicles? What can I leverage in that area to make it better?
Great, thank you. Next question. Is your current pilot implementation related to customer behavioral analytics?
Yes, very much. I cannot speak to that in the full depth as our partners could. This is a scope that's understandably owned by the utilities. They are looking at how the programs are set up, what's the incentive structures, what's the settlement methods for that, and so on, obviously being fed with data and telemetry from the platform, but they are looking at the business model and at the engagement. And there is even a specific behavioral study being conducted in that course as well, with together with NRC. So there is a sort of behavioral research as well, how people respond to different programs, to different price signals, to what's the uninfluenced behavior as a calibration, and so on. So it's a very scientific approach in one specific pilot project. So the Smart Grid Atlantic program, as you see, includes a couple of communities, but there is an element like that which is very dedicatedly looking at the customer engagement and behavior and response to the programs.
Great, thank you. Does your solution target the required zero GHG emissions for 2050 as related to carbon emissions from power generation?
Thanks a lot for the question. Yeah, so first of all, Siemens is very committed to those targets and has more ambitious targets than 2050 for itself. And we have seen and accompanied a couple of energy transitions in a couple of geographies around the world, and we believe that it's feasible. Let's attempt this. There is a chance that we can decarbonize the energy sector, and that we can do that much quicker and much cheaper than anyone had anticipated previously, by leveraging the smartness and the intelligence that we can bring into the system. I really believe that it's worth attempting that, and we hope that the software really gives an additional boost to that development towards greenhouse gas neutrality and the reduction of CO2 target emissions. First of all, if you look at the arrival of carbon tax, conventional energy generation will get more expensive, and you will see more renewables, and someone needs to deal with the challenges that poses. If you can alleviate the challenges that utilities have in integrating all of these new things that are arriving, you can prevent impact on customer rates, you can make the investment lower or smarter, and you can thereby have quite a substantial impact on the acceptance of the energy transition as a whole, if you will. People be also politically willing to support that. We need to find a way that makes it affordable and that makes it a good business idea as well.
Great, thank you very, very much. We're now 2 minutes to time, so this will conclude the webinar. Thank you again, Jacob. Our next corporate partner conversation webinar series will be held on October 8th. Kubra will be presenting innovation in payments, Amazon, Alexa, Facebook, text, and more. On October 13th, Procedure Flow will be presenting on how utilities can train remotely and adapt during COVID-19. All of CEA's future events and webinars can be found in our monthly newsletter, Current Affairs, or you can go to the news and events section on our website at electricity.ca. Thank you very much again to Jacob and to Siemens for the informative webinar today, and thanks to all of our participants for joining today. Until next time, bye for now.